So, hi everyone, welcome back to another lecture of DSA. Today we will be discussing about searching in a rotated array, and our target value here is 0. So we need to search the target 0 in our array, which is named as nums, and it consists of the following elements, if you can see here, right? So it starts from 4, 5, 6, and it goes on till 2. Now, if I allocate the index, this one will be 0, this one will be 1, 2, 3, and then 4, 5, and then 6. So we have till index 6, right? Now I need to find the target 0 in this particular array. So how do we do that? How do we find 0 here? First thing, if you have a careful look in this array, you will find this is kind of like rotated, right? So if I again rewrite this 0, 1, 2, 4, 5, 6, 7, right? So if I rotate one time, if I rotate one time, 7 will come here, and then 0, and then 1, 2, 4, 5, 6. Now, if I again rotate two times, then what will happen? 6 will come here, and then 7, and then 0, 1, 2, then 4, and then 5. Again, if I rotate for the third time, what happens? 5 will come here because this will go in the left side. So 5, 6, 7, and then 0, 1, 2, 4, right? And again, if I rotate for the fourth time, then what comes here? 4, and then 5, and then 6, and then 7, and then 0, 1, 2. Yeah, so basically this is how the final array that we are getting after rotating for the fourth time. And here, if you look at here, this is matching with this one, right? The given array. So this is how we rotate the array, and here we need to find out the target. Our target here is 0. So we need to find the target 0, and the time complexity here should be log n. I cannot again and again run loop to check where the 0 element is at, right? So basically what I need to do is I need to divide the array into two parts, like left and right part, and I need to check, because when you divide the array, it will always cost you log n, which is pretty much a good time complexity if we compare, right? If we compare with the n, or if we compare with the n square, this is pretty much it is like it's pretty good, right? So we need to, based on the log n time complexity, we need to search our target element 0. Now, if we look at here, we can divide this into two parts. So here in the first part, 4, 5, 6, 7 we got, and in the second part, 0, 1, 2 we got. Now, how do we write a code for solving this? What kind of condition can I uh, place in this, right? So first of all, we need to first allocate our left and right. Left is where it will start from the left side. So left side always we will take the index 0, and for the right side, what we will do is we will take the length of nums, right? So basically, we are finding the total length of our array nums, and we are subtracting by -1, because you can see we are not going from 1 to 7, is it? We are going from 0 to 6. That's why we need to decrement the right side by 1, because we are going from 0 to the last element, right? So that is our left and right. What about, and we need to allocate the answer equal to -1, because this is the index at where we will find our 0 element, right? So our case 1, we will be dividing into case 1 and 2 and 3. So here in the case 1, what we are trying to do is we will be finding if, right? We will be finding if nums 0, right, less than or equal to nums mid Now, if you look at this code snippet here, so what is num0? Num0 is nothing but our 4, right? Because this is the 0 index. So we are checking the nums at 0 index, which is 4, and we are trying to check whether it is less than or equal to the nums mid, right? So the nums mid is which one? Mid will be this 7, right? So how do you find a mid? Or we call it as a pivot, right? Pivot or mid, how do you find it? We need to left plus right, we need to sum it up, left and the right, and we need to divide by 2, right? So that is how we find a mid or pivot. So if I check left is 0, right is how much? Right is 1, 2, 3, 4, 5, 6, 7, 7 minus 1, so it becomes 6, right? So our right will be 6, and if we do the divide, it becomes 3. So 0, 1, 2, 3. So basically at index 3, we have got the our pivot element, which is nothing but 7. And what it is doing here in this particular condition is we are trying to check in this particular left side only, right? From 4 to 7. So we are right now in this section. We are right now in this left section, but the condition is target can be on the right side, right? So our target is 0. So our target is here, but we are right now in this section, in the left section. So that is our condition case 1. So in case 1, we are actually in the left side, but our target is on the right side. So that is our case 1. That is how we are searching, right? So if the condition is like that, then what we need to do, we need to change the left equal to mid plus 1, because if you see here, our target is on the right side, so we don't have to search in the left side, on the left side, right? So our mid will change from this, our sorry, our this is the left one, right? When we got started, 4 was the left, but now instead of left pointing to 4, we need to search in this section. So what I'm doing left equal to mid plus 1. So our mid is 7 right now, but now if I increment mid plus 1, then left will be pointing to 0, right? So this is how you control the case 1. What about case 2? Case 2 can be something like we have else if, right? Else if the nums 0 greater than nums mid, right? So if you look at this condition, what it is trying to say is our nums 0, right? So our num 0 is how much? 4. So 4, we are checking 4 with nums mid, right? So 4 is, suppose 4 is greater than 7, right? So here the case here it is totally wrong, but if you assume that 4 is greater than 7, right? So instead of 4 greater than 7, we can write okay. So if you take this array, how much we are having? 5, 6, 7, 0, 1, 2, 4, and the middle is 0, 1, 2, 3. This is the mid. This is the mid for right now. So our lab is pointing at 5, and this is the right. Right is pointing here, and okay, let me write this down. Okay, 5, 6, 7, and then 0, 1, 2, and then 0, 1, 2 we have. So basically left is pointing here, and right will be pointing to this element, and our mid is what? 0, 1, 2, 3. So mid is pointing at 0 right now. Okay. So according to case 2, what we are trying to check is nums 0. So 5 is 5 greater than our mid 0? Yes, that is correct. So that means we will not be in this section. Okay, we will not be in this left side. We are in the right section now. Okay, because 5, we are checking in which direction mid is, right? So 5, you can see 5 is a greater number here, and 0 is the lesser number. So since 5 is greater than 0, that means according to mid, we will be checking. We are right now in this position, in the right position, right? And then what we will do, we will try to check the target. So we are in this right section, and target can be in this section, right? In this left section, target can be. So target is greater than or equal to nums 0. Right? So our target, it should be in this side. That's why we are writing target. Target should be greater than or equal to nums of 0. Right? So that means target is on this side. So that is our condition 2. So what happens when condition is like this? We need to, our right side should be decremented by 1, because since the target is in this left section, on this left section, what we need to check is, we need to check from here to here only. We will not be checking, we will be ignoring this section, this part, right? So that's basically why we are doing right equal to mid minus 1. So mid is this one, 3. So index of mid is 3 right now. So if I do 3 minus 1, then I get 2. So our right will be pointing at this one, right? And our left will be pointing at this one, right? So this is just an example. This is just an example. You can take a different array and you can also check it out. Now we have got the two condition. What about the third condition? The third condition is uh, if the target is on the left side and also we are on the left side right now, then what happens? We will be searching on this left side only. We will not search on the right side. We will discard completely the right side. So that is our case 3, right? Again, inside case 3, we can also write sub case, right? So suppose 5, 6, 7, 0, 1, 2. Now my target is on the right side. Okay. And we will discard the left side because we are right now on the right side and our target is also on the right side. So we will be checking only on the right side. So this is also another sub case. And what we will do is, or if suppose the target is on the middle, right? Suppose my target is on the middle, then what I will do is I will simply write answer equal to mid, because answer was -1, because since we haven't got any index of our target value, we will keep it -1. But here, suppose my target is not on the left and not on the right, it is on the middle, right? So we will give it answer as middle. That is how you will get the answer, right? So you will be dividing the array into sub array left, right, and you will again suppose right now I am checking on this left side. So when I try to check 5, 6, 7, and I'm trying to check the target 6, right? So my middle will become the 6. So we have to keep on searching and we have to divide the array into two parts, right? We have to keep on dividing the array into two parts and we have to search for the middle. And at last we will get the middle. If the target value is existing on the in the array, then we will be finally getting the value, right? We will finally get the mid and the target value equals. When the mid and the target value are equal, then we will be finalizing our target index. So this is how the case works, case 1, 2, and case 3. So I hope you understood the brief idea about searching in a rotated array. Let's jump right into our code. So this is the lead code, and you can just search in a rotated sorted array, and this comes under medium. So let's try to code this. So it is saying that it is saying right from 1 to the size of the array. So between that, our target value will be there. You can see the pivot index will be there between the 1 and the size of the array. So it can be in the middle, or it can be slightly ahead of middle, or slightly behind the middle. So this you have to solve in log n runtime complexity. So your time complexity should be log n. And for each of this input, you should be satisfying the output, right? So like that, you have to, in that order, you have to write the code. So let's get started with the code. So first of all, let's try to define our left and right. So left, I will define it as 0, and then right, I will simply get the length of the nums, right? So you can see this is nothing but the array that they are passing. So we will take this arguments, and we will just find out the length of this array, and we will subtract by -1 to get the right side. And answer, we will keep it as -1 for now, and then we will try to go from left till right. Okay, and then we need to find the mid, because we are running a loop here. You can see we are running the while loop, and inside the while loop, for each iteration, we need to divide the array into left and right sub arrays. That's why we are writing mid equal to, we will write left plus we will write right, and then divide by 2. So you can see here I'm using the double forward slash just to get the integer without any decimal, right? Now, if I check if nums, uh, so we will first try to check on the left side. So now, right now I'm on the left side, and nums mid. So right now I am on the left side, and my target can be on the right side. So target uh, less than nums, then we have 0. So always you will compare with index element at index 0 with the mid and the target. Fine. So suppose I am on the this is nothing but this one, right? So suppose I am in case 1 here. Suppose I am on the left side. Suppose I am on the left side and my target is on the right side. So that is why I need to change my, so I need to search on this right side. So that's why I'm incrementing the left by mid plus 1. So I will do left equal to mid plus 1. Now, it can be such that the uh, target can be on the left side and I'm on the right side, right? So that is why I'm writing this code. So nums and then mid, and then target greater than or equal to nums then 0. Right? So what happens when I am on the right side and target is on the left side? So that means I am on the right side and target is here. So target, we will keep it 6, right? So target is 6, but right now I am on the right side. So what I will do, I will try to search on the left side. I will not be searching on the right side. So what I need to do, I need to change my right. So right is pointing here. I will change to this one. because I would like to search on the left side, right? So left it is okay, we will be starting from here, but the right we will change right equal to mid minus 1, right? So mid was here, now it mid minus 1 means this, and we are assigning that value to right. So right will be pointing to 7. So 5, 6, 7, and we will try to again search in 5, 6, 7, the mid, right? So that is how you will search for the right side. So right equal to mid minus 1. So we have got the two condition. Now for the last condition, it is such that our so in case you can see, right, we can be on the left side as plus the target can be also on the left side. So when both are on the left side, then we will not check the right side. We will totally discard the right side. So for that, we have to write the code like the simple binary search code. So target greater than nums mid, and then so what happens, and then left equal to mid plus 1, right? So if my target greater than nums mid, so that means my target here it is greater than uh, nums mid. So my mid is which one? 1, 2, 3, 4, 5, 6. So let's add another one, 8. Okay, so mid is pointing here, and target is how much? So target is suppose this is 9. Okay, so 5, 6, 7, 8, 9, 1, 2. So target is 9 and the mid is 8. So when my target is greater than mid, then I will not be searching on this side, right? So let me again rewrite this 5, 6, 7, 8, 9, 1, 2, right? Now my target is what? My target is 9 and then the mid value is 8. So if you look at here, target is greater than mid. That means I will not be searching on this side. On the left side, I will not be searching. I will be searching on the right side. That's why we are writing this one. If target is greater than nums mid, then we would like to start the left with mid plus 1. So our left was pointing to here before. Now my left will be pointing to mid plus 1. So my left will be pointing to 9 now, right? So that is how we increment or decrement. We have to play around, and else if target is less than, so target is less than nums mid, then what we have to do is we will be searching on the what left side. So for that, I will just decrement the right by mid minus 1, right? So that's it. And then if finally uh, at some point mid will be equal to what? Mid will be equal to the target value, right? At some point, uh, if you break down into sub arrays from the bigger array, at some point you will be reaching where target will be equal to mid. At that point, we need to assign answer equal to mid, and we need to break the loop, right? And we need to finally return our answer. So this is how it will work, right? So this is how our searching in a rotated sorted array, it is a bit tricky, but it is doable, quite doable, right? So we are finding out the left and the right side, and we are searching on the left as well as we are trying to search in the right, and at some point mid will be equal to the target value that when it reaches at that point, we will try to assign the mid to the answer, and we will try to return the answer. So that is how it will run. So now if I run this, it should not give me any issue. So you can see here I have passed all the case. So case 1, case 2, and case 3. So this is pretty much done. And if I submit, If I submit, you can see it is accepted, right? So that is how we should be able to, you know, solve all these questions. And yeah, we'll see you in the next lecture. Have a nice day and take care.